So, a wonderful good morning, everyone. So, I would like to start off with a question. Who of you has owned or still holding cryptocurrencies? So, Bitcoin, Ethereum, for God forget, Ripple, Gas. So, me too. So, I'm very happy about that. So, I think all of us are excited about blockchain. We all want it to be successful and go through the roof again and then not being a bubble, but staying there. But before I actually go into my talk, I have to say that I am very happy to be here at this event. So thank you, Alan, for continuously organizing this wonderful event, which is a very refreshing format for a telecommunications event and telecom conference. So last year, I think the last talk, if not the very last talk, was already on blockchain. As far as I remember, it was Filecoin. Speaking about how to use distributed networks for file storing and file sharing. And as you just referenced, also the tyntec, winners of tyntec Global use blockchain technology already for their award-winning solutions. So everybody loves blockchain. We all want blockchain to become successful and to be applied in our everyday lives and to bring the revolution to our everyday lives that the media is promising. But I think there are still some things that need to happen for that. Before I continue, for those of you who don't know me, my name is Marco Lafrentz, and thank you very much for the introduction. I work at tyntec as a VP for our communication platform as a service and our inter-carrier messaging services. And the topic for today is that I'm going to share with you the experiences that we have made when we were solving on-chain problems, so problems that you were facing when using blockchain, with already existing off-chain solutions. And the whole topic aims at analyzing what is keeping blockchain from actually going mainstream. So I already referenced media, and the media tends to compare blockchain with the internet. At least from a disruption level, I would agree and say, yes, it will revolutionize our everyday lives sooner or later. But there are some fundamental differences between those two technologies. We all know them. It's not just the fact that blockchain piggybacks on the internet protocol to be actually usable, but they were also created for fundamentally different problems. So the internet was something that was created to share information. And there is a natural curiosity in humans creating an unmatchable demand for information that has led for this technology to be spread freely and openly, and also spread information and share information open and freely across the globe. Now, blockchain technology was designed to perform or to transact value. And if I think about my personal assets, I don't want them to share with anybody else like I want to share information, nor do I want my assets to travel across the globe freely and be accessible by everyone. So those differences, I think, show that there is a difference in design and in purpose, and that blockchain, compared to the internet, needs a little bit more push in order to be like taking over the world. It also shows that blockchain and internet are facing different requirements for them to become actually like accepted by consumers and successful. So if you take the most adopted use cases for blockchain, which is banking or financial transactions, and I don't know if you use Blockfolio to track your assets, I personally do. There was recently a signal where Champana von the Trust Gemini was giving a talk at a conference where he was speaking about the general things that are missing for cryptocurrencies that are existing in traditional banking. And he mentioned three major points. The first thing was that there is no general checks and balances for any transactions like there is in banking. There is only one identifier that is necessary to do a transaction. And the third one, and I need to look it up, is that the transactions are unforgiving. So once you do a mistake, you cannot go back. So, and I think, Dean, you have also published already something about what is keeping blockchain from going mainstream, and you have mentioned some of the problems in a very interesting blog article. So I would like to focus on just one of those three things, which is the piece that says you only need the private key and you can do whatever you want. So if you want to make blockchain acceptable by everyone, you need to meet the requirements of the mob or of the mainstream. And if I think personally about using blockchain for financial transactions, I come across use cases where I give some examples. So what is happening if I lose my banking card? It's not a big deal. I go to my bank, show my ID, and they give me a new card. On the blockchain, if I lose my private key, there is no way I can restore, reclaim my assets, which is a big issue for me to actually trust that system. Another thing is that you do very often is that you try to give authority over your assets to somebody else, to your spouse or to your business partner, so somebody else can do a transaction on your behalf. If you would give away your private key, this person can access your assets like for the entire life, and it will never stop. So temporary access is also something that is not yet there. And the third piece is that I personally like my credit card institute when it sends me a notification and telling me, you know what, Marco, we have blocked the following transaction that was conducted in Romania with 3,000 grand of your credit card last Sunday because it seems suspicious. I like that behavior. So I like that certain transactions can be blocked, and I can also put in like general blocking patterns in my banking account that I say, okay, I do not allow any transactions outside of Germany. Those things are also not possible currently on blockchain. So these easy use cases already show that there are security issues and that there are feature requirements in blockchain. And one of the things that I'm going to do today is I'm going to present a solution that is answering those things now. So we have worked together with a partner that is called Datarella. They are engaged in a couple of initiatives. You go to their website, check them out. They have incredible use cases. They have, for example, deployed a local ecosystem to control and check financial aid that was put into a village in a third world country. So where people actually pay with an eye scan, and the whole economy locally is set up on a blockchain technology. And they set that up in 3 months. It's an amazing story. Go check them out, amazing company. Yeah, so our solution is going to answer some of those things. And I would now like to go a little bit into more detail what the problem was that we were facing and what our solution design looked like. So you have a smart contract that is in charge of performing certain transactions on the blockchain. And if you want to do something on the blockchain, your only identifier is the private key. So if you lose that, you're done. It's over. And there also have been a lot of media announcements where crypto wallet providers didn't really secure like their web interface for the users. So somebody could just hack into the web interface, get the private key, and then they steal the assets. A lot of people lost a lot of money through that. So that's a really big issue. The second problem on that is that smart contracts on blockchain cannot really interface with the outside world. So they cannot just easily call a REST API and do all of the nice services that we already know that exist out there. And the third one is that if you want to introduce an additional layer of security, and we have heard a lot about security already in the first talk, like a passcode, you cannot just store that on the blockchain because it's publicly available and everybody can read it. So our solution to this was that we said, okay, we need a secondary smart contract that is acting, I don't know if you're familiar with the term, like an inbound oracle. So something that is interfacing with an already existing off-chain solution and bringing that features into the blockchain so that the smart contract of the banking backend of Datarella can actually perform a multi-factor authentication on the blockchain. So we all know that if you have a wallet, you go to the website, you get a passcode via SMS, you enter it, and then you're logged in. This is only securing the web front end. It's not securing the actual transaction. So what we're doing is that the smart contract on the blockchain is actually requiring, next to your private key, also an additional one-time password. How this is going to work, I try to, before I go into so I'm sorry, James, I wanted to do a dangerous demo, a live demo. We have done this in July at the Home conference together with Datarella, with their lead developer. He is currently in Tel Aviv and was unfortunately not capable of coming here to Lisbon. So I'm bringing a screencast that was recorded yesterday, where he is showcasing our implementations and our combined systems in action in 2 different ways. And of both of them, I'm quite excited about. The workflow is going to be that somebody is requesting a transaction, and before he can do the transaction, he verifies what he wants to transact, so how much, from where to where, and then he requests a passcode, he gets the passcode, and then the smart contracts process this and check that. Quick reminder for strong authentication. We all know there are 3 types of authentication, and if you use 2 of them, it's considered a strong authentication. So on the one side is the proof of possession, what you have. This is something that we all know. You have your mobile phone, you prove that it's your mobile phone, checkmarked, OTP. The other piece is proof of knowledge. You know your private key or your login credentials or whatever, which is the second factor. So that is considered a strong authentication. And if you really want to be extremely secure, you can add a 3rd layer, proof of being, like a fingerprint scanner or an eye scanner or something like this. So now, if I'm not mistaken, the next slide should be, without further ado, the actual screencast. And I'm very happy to present that. I say a few comments afterwards, proving that it is live. You can actually look up the transactions on Etherscan if you want to afterwards.
Good morning. I'm Michał from Datarella. At Datarella, we develop blockchain-based innovative solutions for and with our clients. In the last weeks, we have been working together with tyntec on a project that enables blockchain transactions to be authorized with second-level authentication in order to increase security of the transactions performed. The security of blockchain transactions today is based primarily on having access to the private key. Once your private key is compromised, there's nothing preventing malicious actors to tap into your wallet and perform unauthorized transactions. Our colleagues at tyntec came up with an idea for adding an additional step to the authentication process, one-time token that gets delivered over SMS. The central piece of the solution is tyntec 2FA smart contract that keeps track of the one-time tokens. You can see it now on my screen. Insert out token function is used to register a new token and its expiration date within the smart contract. Authorize function is used to verify that a given token is correct and still valid. There's also tyntec 2FA protected smart contract that acts as a base contract from which 2FA protected contracts should inherit. It offers authorize modifier that is super easy to use in your smart contract. Functions that are defined with authorized modifier are automatically guarded, and their execution won't be possible if the pass token is not correct. All of the heavy lifting is done within tyntec 2FA contract that we just need to reference. The only change in your smart contract is the inheritance from tyntec 2FA protected and addition of authorize modifier to functions that you want to make secure. The question is, how do those one-time tokens get generated? Client app needs to call tyntec backend with an HTTP call and request a new token. tyntec generates a token, registered is it as a valid token with the smart contract, and then sends user an SMS with the code. User needs to just provide that token when sending a transaction from client in his client app. I have 2 demos that present this concept in action. Let's start with our sample web application. This application stores user private key in the local storage. We want to trigger a transaction from our account to this recipient address. We need to first generate a new token. Let me enter my phone number here. And let's generate the token. We can see that this token has been added to the smart contract with the transaction hash that we just can see here. You can go into the testnet and try to search for this transaction. You can see that it's still pending, so let's give it a moment. In the meantime, I have received my token in a text message. Yeah, and I'll enter the token here. Also specify the amount that I want to transfer, and I send tokens. Now we need to wait for the transaction to be confirmed. It might take a moment. Yeah, and the transaction has been confirmed. We can also check the transaction hash with the testnet. Let's now move on to our mobile application that we integrated with tyntec 2FA in a similar way. So we have our wallet application from which we can send some tokens. I have predefined address of the recipient. Let me enter the amount that I want to transfer. And now it will automatically send one-time passwords with SMS. So let me enter the password here. And I tap confirm. And the transaction has been confirmed with the token that I passed from the SMS. Those two demos show how easy it is to integrate tyntec API with either web or mobile application, and how easy it is to actually get it working very quickly. The most important aspect of it is the execution of the HTTP method that we need to call with tyntec API. It looks like this. This is from our JavaScript code. We just need to pass the address of the contract and the identifier of the user, and then tyntec will take care of the rest. They will generate token, they will deliver the token to the user, and they will store the token in the smart contract. So that for user, it's just enough to copy the token or enter the token into his client app, and the transaction will be secured. We highly enjoyed working with tyntec API on this, and it is truly a very nice and easy to use solution for anybody wanting to make their smart contracts more secure.
Yeah, so thank you, Michael, for the nice words at the end. I didn't really know that he was doing that. So that was, I'm sorry that it was a 7-minute screencast, but although it was a rather long video, I think the information density in the video is still extremely high. And it was also very techy, which I like a lot, so you could actually see the code. And don't be afraid of blockchain code. There are already a couple of SDKs. There are already a couple of environments like Truffle or Ganeshi where you can actually test stuff that help you developing new solutions for blockchain technology. So don't hesitate to try it out. So what we have shown is a working proof of concept in 2 different deployments. One, the public test Ethereum network, and the second piece in the actual private chain of Datarella for their XSC wallet. It's an application that you can actually download in the App Store. So it's not just something that we just created here, it's an actually live product. We have shown the proof of concept integration of an off-chain solution, multi-factor authentication, adding an additional security layer to an on-chain transaction, to a transacted value. What remains to say for the demonstration is that whilst running through this, we already had a lot of inquiries of people that say, okay, I want to buy this. Is this commercially available? Can I get this? And we said, yes, it's technically live. Commercially, it's a different case. Because unfortunately, for the blockchain industry and for those things, there are still a couple of things that are unanswered and that are open, and that we need to face and that we need to also be aware of. There are also some things for this implementation that you face like different situations than in the real world. For example, something that our lead developer, Alex Taloupis, who deserves a lot of credit for what he has built, pointed out is that if you do one-time password via SMS, and I think Telesign can confirm that, is that you don't really think about that somebody can inject a wrong OTP assumption into the actual service provider. So assumingly, we have a client that is requesting from us to do a two-factor authentication. At a certain point in time, we need to tell our customer whether the sent OTP is right or wrong. Well, we can do this on our service. On the blockchain, it's not possible. The blockchain needs to have that information. So we need to provision a hashed information for this check onto the blockchain. Now, we all know that creating blocks is a question of who is the more powerful miner. So it can eventually happen that if somebody's extremely quick and knowledgeable, that he just injects a block with a higher gas that gets processed faster with an OTP that he made up and not the actual tyntec generated OTP. So you need to enrich the OTP information and the hash also with the destination ID to be verified and not just the one-time password. So there is a couple of different perspectives when you adopt solutions from off-chain to on-chain. But on top of that, there are also legal and commercial questions that need to be answered before you can take such services live. So now we're facing a situation where somebody's using a wallet and they trust their wallet provider that everything is secure. So now what happens if our smart contract or the blockchain or the block gets corrupted and the 2FA mechanism doesn't work anymore? The assets are more or less frozen unless you have a capability to reset the smart contract and to change the referenced secondary smart contract. So who is liable in those cases? That is an open question that we're still facing. What else do we have? If you develop such things and you want to go to market with those early products, your company has to face the situation where you need to answer for yourself, what is the risk that I'm willing to take and the responsibility compared to my return of investment that I can get? And of course, this is also questioning how fast can I scale this up? And I've said earlier that end-user adoption is something that is extremely important, so we need to get comfort of consumers into that technology, into the everyday usage, to get that generally accepted and rolled out globally, to become as disruptive as we want the technology to be. So these are my closing remarks on what we have seen. We were very excited in doing this. This was a lot of fun for the developers as well as for the product managers and for our companies as well. If you're a blockchain company and you're interested in using telecommunication services for your blockchain-based solutions, we're here. There is also Gene and Jens from our team. You can quickly wave your hands. We're more than happy to talk to you about what we can do together, and we will be standing over there too. Or if it's the other way around, and you say, okay, I know your use cases, programmable telco, I have a blockchain feature that you might want to integrate into your use cases that is going to make the use case more powerful and attractive, we're also happy to talk about that. Because that goes vice versa. New technologies can do something for the old school world and the other way around too. So with that, I would like to thank you for your attention, and I'm looking forward to this event. And happy to talk to all of you. Have a great show. I hope you enjoyed the last 20 minutes. Thank you.
Thank you so much, Marco. Any questions for Marco? Unfortunately, we just have time for one. If not, I'll ask in my prepared stack of questions. One of the nice things with tyntec is you work a lot direct with enterprises. This is a great example of building solutions with a particular enterprise. What you are interested in your perspective, given all the work you do with enterprises, which verticals are driving greater solution focus? So where you're seeing more demand, not just for your vanilla APIs, but for doing projects like this?
For the productive industries, demand drivers and revenue drivers are not necessarily the same. So when you go into the space currently where you see revenue drivers, you definitely have everything that is chat related. Customer support, customer engagement, employee communications, everything that is two-way chat, that is currently growth rates that are amazing. When you think about what is pushing technology to the next level and asking for more innovative solutions, and of course the ROI only comes with the productivity stage thereafter, not just with going to build out the new stuff. Interestingly enough, you have a couple of governmental-owned clients that push that because they have special requirements in certain areas that are very unique and special. Specifically, when you go into the area of blockchain, where you have the capability of auditing, of tracking transactions, of reporting correctly, and ensuring that everything went smooth, this is definitely an area that is also of interest for us.
Excellent. Thank you so much, Marco. Again, a great round of applause for a great presentation and a demo.